Placer gold has fascinated miners, prospectors, and geologists for centuries. From early river panning to modern industrial recovery, the story of placer mining is one of persistence, ingenuity, and transformation. In this 10-minute explainer, we'll cover every stage: prospecting, world placers, recovery methods, hard rock connections, refining, and the economic legacy that still shapes gold mining today. Finding placer gold starts with reading the land. Rivers create natural traps where heavy gold settles, behind boulders, in riffle zones, or on false bedrock layers made of clay or compacted gravels. Black sands, rich in magnetite and ilmenite, act as a natural clue, often concentrating with fine gold. But rivers aren't the only places to look. Bench placers, ancient river channels perched above modern valleys, can hold forgotten pay streaks. In deserts, alluvial fans spread out gold-bearing gravels where flash floods deposit material. The prospector's job is to recognize these patterns and sample smartly, turning geology into guidance. Gold placers have shaped history across the globe. In California and the Klondike, contrasting deposits produced everything from fine dust to massive nuggets. Australia's outback still yields monster nuggets, while South America's rivers in Brazil and Peru have supported placer mining for centuries. Africa's alluvial fields in Ghana, Sudan, and South Africa remain active today, and in Siberia and the Arctic, frozen ground poses unique challenges. Every region tells a different story, but the principle remains the same. Water and gravity concentrate gold where it can be recovered. Placer recovery has evolved, but the physics hasn't changed. A pan remains the simplest tool, relying on swirling water to separate gold from lighter grains. Sluice boxes with riffles and mats trap gold more efficiently, while 19th century miners used long toms and rockers to process higher volumes. Modern operations scale this up with dredges, capable of moving thousands of yards of gravel, or shaker tables, that separate gold by vibration and gravity. These methods show the continuity between old technology and today's industrial approaches. Placer deposits are often just the first clue. Many lead back to hard rock lodes where gold formed in quartz veins. Detecting nuggets with metal detectors can guide prospectors toward richer zones. Crushing ore, from hand stamps to modern jaw mills, frees gold for further recovery. Historic miners often used mercury amalgamation to capture fine gold, but this came with major risks. Cyanide leaching eventually replaced mercury, allowing much higher recovery from low-grade ore. These steps connect surface placers with the deeper geology that created them. Once concentrates are collected, the journey isn't over. Smelting at home with fluxes like borax or soda ash produces door buttons. Fire assay, an ancient method still used today, remains the most accurate test of gold content. At the industrial scale, electrolytic refining achieves 99.99% purity by plating gold onto cathodes. Finally, molten gold is poured into molds to cast ingots, stamped and certified for trade. These steps transform raw gravels into bullion bars, the gold standard of value. Gold rushes created both winners and losers. While a few miners struck it rich, merchants, railroads, and banks profited most. Boomtowns rose and fell, leaving ghost towns behind. Today, modern placer mining in Alaska and the Yukon continues on a regulated industrial scale with excavators, trommels, and reclamation rules. But gold rush legacies remain in the environment. Mercury contamination still pollutes rivers, and cyanide spills remind us of the risks. At the same time, small-scale miners and industrial giants each play their role in global gold supply, with new technologies, AI, drones, and sensors, pointing toward a future of cleaner, smarter placer mining. From reading rivers to casting bullion, placer mining is the bridge between nature's processes and human ingenuity. Its story is one of persistence, adaptation, and discovery. The gold of tomorrow will still come from rivers and gravels, but guided by technology and shaped by the lessons of history.